looking at solving quadratic-like equations. So first off, the general quadratic equation is given by ax squared plus bx plus c equals to 0, as we all know. And then the general quadratic formula is given by x equals to negative b plus or negative square root of b squared negative 4ac over 2a. So what we're looking at in this video basically is solving equations that resemble quadratic functions, in which we could get a quadratic function out of it and get the solutions of such equations. So we're going to start with the first question. And the question is, solve the equation below for the real values of x that satisfy. And it goes like 2x negative 3 all squared negative 4 all over 2x negative 3 all squared negative 3 equal to 0. So if you look at this equation, you can notice a similarity between the elements of this equation. So first off, we have 2x negative 3 all squared, and we have 2x negative 3 all squared, negative 3 all squared as part of the second element of this equation. So we could solve this equation through a substitution. We could say that 2x negative 3 all squared should be a. So basically, you could say let 2x negative 3 all squared be equal to a. Then we're going to have a negative 4 over a. Negative 3 equal to 0. That's kind of like a substitution. Then to resolve this, we have to clear the fractions. We need to clear the denominator. And if you look at this, the LCMs of this stuffs right here, 1, 1, and a. So the LCM of 1a, 1 is a. So we can multiply every element of this equation through by a. So if we multiply through by a times a is going to give us a squared, right? 4 over a times a is going to give us negative 4. And negative 3 times a is negative 3. So we have basically this. Having this, we have a squared negative 4 negative 3a, which is same as a squared negative 3a negative 4, which is in resemblance to the general quadratic formula. So the highest power of the function is 2. So we then compare with the general quadratic form, and then we realize that a is 1, b is negative 3, and c is negative 4. Why? Because the coefficient of a squared in this equation is 1, the coefficient of a is negative 3, and the constant term is negative 4. So we resolve the numerator of this that equation, and remember the quadratic formula x equals to negative b plus or negative square root of b squared negative 4ac all over 2a. So all we do is to substitute. So we have negative b, so b is negative 3, so we have negative 3 plus or negative square root of b squared negative 4ac. So b negative 3 squared negative 4 times 1 times c negative 4. So negative 3 squared, negative times negative is positive, so 3 squared we have positive 9, and negative 4 times negative 4 is positive 16. So we have 9 plus 16. 9 plus 16 is 25. So basically we have 3 plus or negative square root of 25. And square root of 25 is 5 because 5 times 5 is 25. So we can have 3 plus or negative 5 equal to 8 because 3 plus 5 is 8, and 3 negative 5, that's 3 taking away 5, we're going to have negative 2. So to resolve the denominator of the quadratic formula, remember the value of a is 1. The coefficient of a squared in that expression was 1. So 2 times 1 would be the denominator. So 2 times 1 is 2. So that's the denominator. So we divide each of these values by 2. 8 divided 2 and negative 2 divided by 2. So 8 divided 2 is going to give us 4. And negative 2 divided 2 is negative 1. So we have 4 or negative 1. So we've gotten the two possible values of a. So if we go back earlier in this equation, remember what we did. We said that let 2x negative 3 all squared be equal to a. So we could basically say that 2x negative 3 all squared is equal to 4, or 2x negative 3 squared equal to negative 1. We'll only be solving the first part of this equation because according to the question, we're told to get the real values of x that satisfy. If we solve the second part of the equation, the second part of the equation is saying 2x negative 3 all squared equal to negative 1. And the solutions to this is imaginary. So we'll only solve this part. So we have 2x negative 3 all squared equal to 4. So we'll take the square root of both sides. And if you take the square root of 2x negative 3 all squared, we're going to be left with 2x negative 3. And then if you take the square root of 4, it's either 2 or negative 2. Those are two possible values. So at a equal to 2, that's, remember, 2x negative 3 all squared is equal to, a. So 2x negative 3 is equal to 2. So 2x negative 3 equal to 2, yeah? So this negative 3 right here is going to move to the right-hand side of the equation and become 3 plus 2. That's going to be 5. So 2x equal to 5, right? So x equal to 5. Then to get the value of x, we divide 3 by 2. Then we're going to have 5 divided by 2. We're dividing 3. So x is going to be 5 over 2, which is equivalent to 2.5. And then remember to say a is also negative 2, right? Negative 2. So at a equal to negative 2, 2x negative 3 will be equal to negative 2, right? So 2x negative 3 crosses to the right-hand side of the equation, and we have negative 2 plus 3 because sign has changed. And then negative 2 plus 3 is 1. Then if you have 2x equal to 1, we'll divide 3 by 2 to get the value of x. And the value of x will be half. So the value of x is half, or 2.5. So take the second question. It says, showing all necessary working, solve the equation 4x negative 11 root x plus 6 equal to 0. So best approach to this is also a quadratic-like equation, is to take the negative 11 root x to the right-hand side of the equation. And when we do that, we're going to have 4x plus 6 equal to 11 root x. So to simplify this, all we need to do is to find the square of both sides so that we will not have a square roots sign in any part of this equation, so that we just have x and we just have x squared. And squaring both sides of the equation is going to lead us to a quadratic equation, which is a step behind getting the solutions to the equation. So then we're now going to have 4x plus 6 all squared equal to 11 root x all squared. Yeah. So we're going to find 4x plus 6 all squared equal to 11 squared is 121. And then root x all squared is x. Root x times root x is x. So we're going to now solve this equation. So then, first of all, we expand 4x plus 6 all squared. 4x plus 6 all squared is the same as 4x plus 6 times 4x plus 6. So taking from here, 4x times 4x plus 6 plus 6 times 4x plus 6 is how to expand it. So 4x times 4x is going to give us 16x squared. Plus 4x times 6 is 24x. 6 times 4x is 24x. And 6 times 6 is 36. So we have 16x squared plus 24x plus 24x plus 36. So simplifying that, we'll have 16x squared plus 48x, because 24 plus 24 is 48, plus 48x plus 36. I remember that 4x plus 6 all squared was equal to 21x, so we're going to have this. So we could take that 121x to the left-hand side of the equation, and then we're going to have 16x squared plus 48x negative 121x plus 36 equal to 0. And 48 negative 121 is negative 73. So we have 16x squared negative 73x plus 36 equal to 0, which is now quadratic. So we then substitute in the general quadratic formula, So ax squared plus bx plus c equal to 0. So in this case, a is 16 because that's the coefficient of x squared, b is negative 73, and c, which is the constant term, is 36. So all we need to do is to substitute in the quadratic formula, which is negative b plus or negative square root of b squared negative 4ac all over 2a. So we just substitute the values. So in this case, B is what? Negative 73. C is 36. And A is 16. So then we use the quadratic formula, negative b plus or negative square root of b squared negative 4ac over 2a. So we then resolve the numerator of the equation. So negative 73, because b is negative 73, plus or negative square root of b squared, that's negative 73 squared, negative 4 times a, which is 16, times c, which is 36. So negative 73 squared, negative times negative is positive, and 73 squared is 5329. Negative 4 times 16 is 64, times 36, that's 2304. So 5329 negative 2304 is 3025. And the square root of 3025 is 55, because 55 times 55 is 3025. So we have 73 plus or negative 55 as our numerator. So if we add 73 plus 55, we have 128. And if we subtract, we're going to have 73 minus 55, which is 18. So the numerator is taking values 128 or 18. Then we resolve the denominator. The denominator is 2a, right? And the value of a in this case was 16. So 2 times 16 is 32. So we divide each of this value and this value by 2. So 128 divide 32, sorry, by dividing by 2a. So 128 divided by 32 is 4. And 18 divided by 32, if we reduce this, 2 into 18 is going to give us 9, and 2 into 32 is going to give us 16. So that implies that x is equal to 4, or x is equal to 9 over 16. Then we're going to take the last question, another way in which a function could be said to be quadratic-like. And it goes like this. Find the values of x that satisfy the equation x to the power 4 negative 5x squared plus 6 equal to 0. So to solve this equation, we need to do some form of substitution to get a quadratic, that's a resemblance of a quadratic equation. So the step towards this is to use the power law of indices, which is that we have x squared raised to the power 2. X squared raised to the power 2 is same as x raised to the power 4, because x raised to the power a, right, raised to the power b is the same thing as x raised to the power ab. X raised to the power ab. So then it could be written like this. So we could bring up a substitution and we can say, let x squared be equal to a. So at the end point, if we should say x squared equal to a, then we can write a squared, because x squared is going to give us x raised to the power 4, and negative 5 x squared, and x squared is a. So we have a squared negative 5a plus 6 equal to 0. So this equation, we could solve it. We may not even need the quadratic formula. I made a video on solving a quadratic equation by factoring, and in this case we could typically guess the factors that we're gonna multiply, that is gonna give us 6, and we're gonna add, that's gonna give us negative 5. And those two factors is negative 2 and negative 3. Why? Because negative 2 negative 3a, negative 2 negative 3 is negative 5, and negative 2 times negative 3 is positive 6. So we can factorize. We look at what is common between a squared and negative 2a, and that's simply a. So if we divide a squared by a, we're going to be left with a, and 2a divided a is 2. So we have a bracket a negative 2. And then if we look at negative 3a and plus 6, the stuff common is negative 3. So if we take out negative 3, negative 3a divided by negative 3 is a positive a, and 6 divided by negative 3 is negative 2. So we take this, that's a, and we take negative 3's. So taking that, we have a, negative 3 times a, negative 2 equal to 0. And according to one of my past videos, if we should say that two factors equal to 0, it's either the first factor equals 0 or the second factor does. So it's either a negative 3 is equal to 0 or a negative 2 equal to 0. So a is equal to 3 or a is equal to 2. So then we have to recall, remember that at the earlier part of the video, we said that x squared is equal to a. So we have to recall that x squared is equal to a. And we've gotten the values of a as either 3 or 2. So having that, we could basically say that x squared is equal to 3 or x squared is equal to 2. So to remove the squared and x, we take the square root of both sides. And then to remove the squared from this, we find the square root of both sides. So then we are now going to have x equal to plus or negative root 3 or x equal to plus or negative root 2, because we have two possible solutions for the square root of a number. It's either it's positive or negative, because negative times negative is positive. So x is equal to plus or negative root 3 or x equal to plus or negative root 2. Thanks you for watching this video. Thanks for watching to this point. I encourage you to subscribe, like and share this video, and also do well to comment, subscribe to get more content similar to this. And I say big thank you for watching this video. That'll be all.